The state that a substance is in has a lot to do with the temperature. The particles in a system vibrate or move around. They have energy in their kinetic energy stores. They also have energy in their potential energy stores due to their position, but you don't need to worry about this. The energy stored in a system is stored by its particles, atoms, and molecules. The internal energy of a system is the total energy that its particles have in their kinetic and potential energy stores. Heating the system transfers energy to the particles. The size of the temperature change depends on the mass of the substance, what it's made of, its specific heat capacity, and the energy input. If the substance is heated enough, the particles will have enough energy in their kinetic energy stores to break the bonds holding them together. This means you get a change of state. We spent some time last week practicing using the specific heat capacity equation. Make sure you remember all of the stuff on specific heat capacity from module P1, particularly how to use the formula. You should also recognize the definition. When you heat a liquid, it boils or evaporates and becomes a gas. When you heat a solid, it melts and becomes a liquid, or sublimates to become a gas. These are both changes of state. The state can also change due to cooling. Energy is transferred from the kinetic energy store of the particles, so they move slower and start to form bonds. They don't have enough energy to overcome the bonds. All the changes of state are shown in this picture. A change of state is a physical change rather than a chemical change. This means you don't end up with a new substance. It's the same substance as you started with, just in a different form. If you reverse a change of state, e.g. freeze a substance that has been melted, the substance will return to its original form and get back its original properties. The number of particles doesn't change, they're just arranged differently. This means that mass is conserved. None of it is lost when the substance changes state. When a substance is melting or boiling, you're still putting energy in, so increasing the internal energy. But the energy is used for breaking intermolecular bonds rather than raising the temperature. There are flat spots on the heating graph where energy is being transferred by heating but not being used to change the temperature. When a substance is condensing or freezing, bonds are forming between particles, which releases energy. This means the internal energy decreases, but the temperature doesn't go down until all the substance has turned to a liquid, condensing, or a solid, freezing. The flat parts of the graphs show the energy being transferred during the change of state. From this video, you should know or be able to describe how substances change state. That you should recognize that mass is conserved. You should know the changes of state are physical changes, so they can change back. They don't have new products made. You should know that energy is stored inside the system by the particles. They have kinetic and potential energy, and added together that makes internal energy. You should know that heating changes the energy stored within the system, and increasing the energy of the particles by raising the temperature will produce this change of state. You should also remember how to use the change of thermal energy or the energy transfer specific heat capacity equation so that you can work out how much energy is being transferred while it is in a particular state of matter. And you should know the definition of the specific heat capacity. So go back to Google Classroom, add your answer to the question that came with this video, and then I will get on with the next video because we are quite far behind in this topic, and that was my fault for getting a cold, but I'm back on it now and we will catch up soon.